Welcome to this episode of the Europa webinars. My name is Henrik Helgesen. I'm going to be the moderator for this session. This is the 92nd episode of the Europa webinar, so welcome back to our repeat viewers, and of course welcome to any first-time viewers we have here today. Today we have Christoffer Andersen, a fellow Dane, and together with Luc van Vugt, talking about the lightning-fast test automation and solidized code and a revised test plan. Before we get started, a couple of housekeeping rules. Please keep your mic muted. If you have any questions, please post them in the GoToWebinar question window, and I will be moderating the questions and making sure our presenters get the questions. If you're not able to catch the webinars live, all the webinars are recorded and are put on YouTube. So there's at this point a great library of videos on YouTube/Europa webinars. And to be sure that you are kept up to date with upcoming webinars, you can sign up for the newsletter and at this link here on eepurl.com. This is the 92nd edition of the webinars, but as you can see, we have many more webinars in the pipeline already. Monday, September 30th, we have AL Everywhere, local deployment versus Azure Cloud. October 14th, also a Monday, we have a session on the REST client module in AL. October 28th, we have on page scripting, and on November 11th, what about modular monolith in AL? Elastic's leadership applied for development teams on November 25. And in December, we have grabbing BC artifacts in your pipeline via an Azure function. And in January, at this point, we have the automating code quality. That's a rescheduled from September 30th. We want to thank our sponsors, Fornav, for making these webinars possible. And at this point in time, I will let the presenters actually do some presentation.
Yes, thank you very much. I'll just take over. Go.
Yeah,
Are you seeing my screen now?
Yeah, we're online.
Well, welcome to Lightning Fast Test Automation, Solidized Code, and a revised test plan. Hopefully, a lot of you recognize this. This is the test suite in Business Central, where we, of course, write all our tests and we run them. However, if we are doing it the traditional end-to-end way, where we have a lot of givens, etc., we can see the execution time stacks up, and not only the execution time, but also the complexity of the tests stacks up, and that leads to slow adoption and, in the end, complete abandonment of testing. And we will go through this, and this is me. I'm Christoffer Andersen. I'm a lead developer and TSA at Evidi, and I have started working in Business Central in 2019, where I was hired to transition from C-side to AL. Yeah, as you can see, I love to try to implement good coding thoughts, which is completely possible in AL. And then we have Luc.
Yeah, good evening, and great to be here with you, Christoffer. A long journey that we've gone, and this is one of the, we could say, end stages. I'm working for 4PS as test lead or test automation lead. Been around quite a while. Let's say I'm the bold dinosaur, and Christoffer is the guy who challenged me on a lot of things, and that's what we're going to present today. So please move on.
Yes.
So we met a year ago, or a little over a year ago, at BC Tech Days 2023, when I did a web workshop on test automation, writing test automation, and we discussed a lot of things. And well, Christoffer was there and was challenging me, especially as he had done a workshop the day before, let's say solid coding by Vugt, and there is where we more or less well, I invited and Christoffer gladly accepted to get on this together and find out how can we combine a test plan, the functional side you could say, and getting into test automation, more testing components than just full flow. So that's where it started. What is our objective today? First of all, we want to show you that data setup highly depends on code structure, and how can we optimize that code structure, and thus also the data setup. How to move from componentized code to solid code. So if you can optimize your structuring components, how could you move further? And how to find a balance between solid and componentized code. That's the goals of today. And yes, in the end, I'm interested to keep those two, the test plan, and finally your technical implementation in unit and testable units together. That leads to an agenda that is quickly shown here. We're not going to mention everything, but you will see, we'll go through all of this during this session, and sometimes a step into code structure again, and then into the test plan. So, well, you will see. So let's start with our story, Chris.
Yes. The first step in testing is understanding what to test, because we don't want to test all of Microsoft's logic. We are responsible for what we do, what we code, what we have created, what we have extended, if it's logic on table extension or if we have our own things. But we are not building our tests to test whether or not an insert work in Microsoft code if we haven't done anything specific regarding the insert. We are not testing if the sale post is working. Microsoft has tests for that, and we can run them if we want to. Sure, that's a perfectly good thing to do, but that's not the purpose of our tests. That include features like data access, page rendering, and most of the time we should trust that Microsoft tests that. Of course, sometimes something goes wrong, but that's not the purpose of our tests. That will be picked up quite quickly if anything goes wrong. So again, test only your business logic and identify what in your business logic you want to test.
So let's have a, sorry, yeah, go ahead.
It's your turn.
Well, we're sitting not next to each other, so it's quite a challenge to do that. So data setup and code structure. Let's have a look at that one and see what that means. So if we have one business case, and we'll look at it first from, let's say, old-fashioned code, what we might call spaghetti, like things stuck together, straightforward programming. The business case here is a case that some of you might know because of courses that I've been leading, seminar registration posting. In short, it's a module in which you have defined seminars that you can plan by structure of a document, and eventually when the seminar has been executed and closed, it can be posted. You can see here roughly the flow of that posting, and that's the basis to our story. We're not going to show you everything, but I think you know all Code Unit 80, Code Unit 90. This is a simple version of that, posting a document. So we take out from this schema 3 parts. Yeah, as you can see, check mandatory header fields, lines exists, and check line. Yeah, 3 parts that will implement or are implemented as new business logic. And these 3 are the repeating parts in our story. Of course, there's much more, but let's keep it simple. So those 3 parts are in this one spaghetti code tube, you could say. If you want to test it, if you want to execute it, you need to start on the left side in, and eventually on the right side, you get the result. Of course, you could have exceptions, errors, and then the system just takes a back door and jumps out of the flow. But whenever you want to touch something, one of those 3 components, you need to start at the left. So in essence, it's a full end-to-end testing with also high database dependencies. Yeah, so inserts are being done, lines exist, checks whether there are things in the database. And altogether, we have a complex data setup. We could have a look at this closer. Just move on if you want to. We could restructure it to be it more in components like this. It looks like components, so we have this unrun part, let's say condensed, calling up on the different parts on the right side, the swim lanes, like check and update, copy comment lines, etc., etc. But if we look at the, let's say, the overall structure, it's still a tube. Yeah, even though we have structured it better. Previously, that spaghetti was one big flow, although the flow diagram showed you different parts. But in essence, the code was like code unit 80 some years ago, 100 or 1200 lines almost in the on-run trigger. So, this is still spaghetti. If you want to test it, it's still full end-to-end, still high database complexity or dependency, sorry, and a complex data setup. So what did you gain? Maybe, well, the only thing that you did gain is that it's better readable, and that's it. If we look at the data setup part, and you might recognize the upper side, this is typically how I structure my tests in different test scenarios, and then the details given when then. And here you see that we already had 5 or 6 given. So with structured or unstructured spaghetti, you have to go the whole flow, yeah, complex data setup. And what about that one? We can make that more efficient and effective. I have been talking about this. We did a workshop on that also at Tech Days. It's not something we're going to discuss into detail, but let's take out this scenario and look at this given part and what we could optimize. So this is the data setup, and as we do a full end-to-end, we need to set up the whole thing. You don't have a real choice. Well, you have some choice, but there is a price to it. Let's have a look at it. So if you look at the code, you see here at the, so we have this spaghetti flow, even though structured. This is the full spaghetti, by the way, not structured. So that's, we need to flow from top to bottom, yeah? And if you have a look at the test code, you will see givens at the top, yeah? And if you even go down, you will see those givens still reappearing, yeah? So every test is more or less a variation of the previous one. If we go back to the slides, then and move on, then you could say, what options do we have to make it more effective? Don't use the UI, only use code to do things. Don't go and clean up things. So don't clean up the database before you do a test. Don't clean up things after you do your test. Promote things that can be reused, what I call from fresh to shared fixture. If you have a customer in every test created, and actually you could reuse them, yeah. Another thing is only set up what is needed, and that's typically something Chris will also hook up into, that we could be more effective in these tests. Like if it touches an error and data setup is done for anything after the error, we could leave that out. So only set up what is needed. But nevertheless, if you would change the order of the code, then all of a sudden your test will fall over because you didn't set up the data, you changed the order, and now the data was needed. So it's possible, but it comes to a bit of a price. And a last one, what makes data setup also very effective: creating data, don't use calls to validate because they call more code. Getting data set up is just getting the data in place. It's not about running the business logic. If you do this, and you will see that this benchmark, that indeed your test will run faster. And you could say roughly it gets twice faster than with the full data setup and full run. Okay, let's move to the next one. This is an overview of the data itself. If you need it later on, if you want to need more about it, contact me. So altogether, if you look at this, what are the pros? You have it still a direct correlation with functional floats and data handling, true, but that's a cost. The cons are you have extensive data setup. It's not only that it takes more time when running, which you want to save on, but also setting up. Me as a developer, it takes quite some time to find out all the givens. Sometimes it takes a day for me before a test is really ready, and then I can copy it for any other variation. And as said, with this thing hitting an error and not setting the data up for anything after the error, there's a fragile correlation with code structure. If I change the code, the order of the code execution, that, let's say, efficient setup of my tests is no longer helpful anymore. It's actually giving me more work. So what's next is, okay, what can we do with the code structure? And that's, well, where you are up to. Yes.
So the first step has already been taken to identify the areas which we want to run our tests upon. As we've seen in the structured spaghetti, we had to check mandatory header fields, line exists, and check lines. But now, and the same in the componentized, we simply just take these and extract them from our original code. We encapsulate them in another code unit, which we can call with the procedure. See that? That means that there's still a high database dependency. We're still using all the records, etc., but a less complex data setup, because now if we're going to test the check lines, as an example, we're only going to focus on the givens for that specific check lines and not the entire flow of the code. And we'll just look a bit on that. So just switch here to the structured spaghetti, which is here. And if we go into the structured spaghetti, we will see we have the check and update we had from earlier on, and that has check mandatory header fields, which was the one we were looking at with the givens alongside the other ones. This has now been isolated in a seminar validator code unit, where the three components we want to test upon have been extracted to each the different procedures. Nothing else. It's simply just been moved out, and they now take the record as a parameter. And that means that when we go through the different component tests, now I only need to have a given of a similar registration with an invalid status, here where I check the status invalid, rather than having all the other givens we remember being there from before. As we can see, these were the givens for before with the empty posting date, and now I simply just have an invalid posting date, one given which is created without validate or anything, where I just provide enough test data to reach my condition for the tests. As we can see, running that compared to the optimized code is actually equal, more or less. And we actually also need one extra test to ensure that we can go through all of the components. So it introduced some more tests, and we don't really gain more speed, but the complexity of the tests written for the components are so much easier to maintain. And if we break it down, we see it's approximately the same. So to sum up, we moved from the unstructured spaghetti, and we then went on to the structured spaghetti, and then we took our three areas, isolated, and pulled them out. But that means that our test plan needs to be reworked in order to actually support these components. And how are we going to do that, Luke?
I want to stick or keep a relation between test plan and what we do with the code. So let's have a look at that. You could say, well, this is the basic test plan, what we're looking at. We have 11 tests. If you look closer, we post a closed seminar registration. That's the happy flow that should go through the whole thing. Then we have parts where we check the header part, like Christoffer also showed, and we have parts where we look at the lines. If we look at the details, so what are exactly those scenarios and how do they relate to the business logic that we want to implement actually? So if you look at this here, now you see that I changed some coloring also, but also the fact that at the first, you could see the first test is an implementation test. It will run really through the code in that marked section with the red line. You see, this is one unit actually, having 7 tests of which the second one will be an implementation test, so that we will run the whole test through the real code. Yeah. If you look at the next part, you see two more components. So what is the relation between the test plan and the unit testing is actually that we can see from the scenarios, hey, there is a group of 7 tests that relate to each other. That will be a component. Yeah, of course, we already said that it's a component, but in my daily life, it's setting up a test plan first before you even build things. Yeah, and you can see we identify in the test plan 3 components. Yeah, and as Christoffer said, we still have a whole bunch of tests, but we have now tests that only test units. And if we take a look at the units, you see that we add an extra test. I said we had 7 tests, yeah, the red marked one, and then for the unit to test, we will add an extra test to only check the unit in a happy flow so that everything is working right. It's a positive test. You see the red marking things are positive, negative, because they will hit upon an error. Yeah. And in the next one, for the line parts, so check mandatory lines or check that line exists, we will have the 2 positive, negative, which were part of the full flow also, and we'll add an additional happy flow one, so one that will have a positive result. Yeah. So if you look at this, let's say, splitting up of things, you will see that we do still have those 13 tests, original tests. And you can move on to the next. Yeah, so we have 12 costly implementation tests originally, and we moved away from that into 4 costly ones, still running through the whole code because we still have that pipe starting from the left, moving into the right, but we don't need to do that for all of those scenarios. 4 will do more or less from the start everything they can do, and the other remaining 13 are unit tests. So we don't need to test the whole flow for all of them. So what does it mean, or how can we go further? But before we do, what are the pros and cons? You get a better structured code, and each component has less complexity. It's easier to understand and test with less givens. If you're testing the components, there's not a lot of data setup to be done. It's actually 1 or 2 or whatever parameters you need to hand over to the method. Yeah, and your set of tests is way less intensive. Yeah, cons, of course, with every pros there are cons. You need to re-engineer your code. Yeah, and yes, you need to expose your components as non-local procedures. Otherwise, you can't test. Our platform doesn't allow to test locals, so you need to set them to internal. And as you can see, the last bullet, red marked, more or less, is if you have in your production code components that are set to internal, you need to expose them through internal visible to part in your app JSON to your test app. And that's let's say a vulnerability potentially. If you don't remove that when you release your app, others could hijack that one and make use of that. Whatever it will be, it might not be that dramatic, but it's a vulnerability. Okay, let's go to the next part where we, let's say, move out of those components and see if we can apply solid principles.
Yes, so solid principles have been around for quite some time, and it's actually a code independent way of thinking where we have the solid, and it simply stands for single responsibility principle. Whatever your code is doing, it's doing just that. Open close principle, that's, you can access the outer procedures and the locals locked down. You can substitute everything, and you can represent everything with an interface, and you will not have a direct dependency on the database, as an example. And that's a challenge to remove from Business Central, but we've done it, and there are some pros and cons which we will go through here. So when moving from componentized to solidized code, we'll go back to our seminar registration post, which we already know. We still have these three areas, which we have already moved out to a componentized logic, which we saw before. So we had the seminar post who were communicating with the seminar validator. Now, in order to solidify this thought, we will need to remove the dependencies on the database, and we will need to represent everything with an interface. So if you go through it, we will have a factory. We will demo that afterwards, which will take the three different areas which we have extracted, and now we have moved them to three different components represented by three different interfaces. They could be in the same interface if you want to. That's just a matter of how you want to structure, how you want to replace different components during a flow, which we will get back to. And we see here that the seminar post now have the registration header, which is a table, and that's represented by an iRegistration header, which will come from the seminar registration header. And we will see just a short demo on that. So if we go down to this, we will take and switch to the solid component. So we can just close this down and this down. And here we have the solid. So here we have the solid chains. And we see here that we have a factory introduced. And the factory is used to keep track on which implementation of the interfaces we are using at runtime, like dependency injection. And we can see when it's run itself, it will simply just take this factory, which we have here, and the factory has a registration header validator, it has a registration line validator, and a registration line existence, a get, a set on those. And we can see it will simply just take these registration and inject them. If you go into the registration header validator, we can see this has implemented the check mandatory header fields from before, and it now takes an interface of a registration header, which has a status, a posting date, document date, etc., as a procedure, which represents the fields earlier from the table. Now, since we don't have the database, we don't have the test fields anymore, so now we need to actually check if a document date is 0 date, throw some errors, etc. I'm going to go through that. This means that we can now provide whatever database independent thing we want to test upon. So in the check mandatory header fields invalid status, we'll simply not provide a table, but a stop, which implements the registration header and simply just exits some values where we have something giving the wrong status, which we are testing upon. So the given, there's not anything written here because it simply just takes a stop, and we see it uses the registration header validator from before, which represented the check mandatory header fields. Now, then we can access the full end-to-end test we had from early on, the post-close seminar registration header. But here we have the factory from earlier, and we actually inject that into our seminar post, where we inject our own validators for header, line, and line existence, because we don't want to actually run them anymore. We don't care about whether or not they fail. We just want to make certain that they are reached. So if we see the registration header validator is taking a SPY header validator, which if we go into it, simply just implements the iRegistration header validator and sets a Boolean. And it could be a timestamp if you want to ensure that it's reached in a certain order, a dictionary, whatever you want to be certain that you reached your code. And once all of this expensive have been run through, where we had all the verifiers from before, we now have simply to say, have our components been reached? So given that we completely detach or decouple it from the database, it has some advantages. We can easily reuse everything out of the box. I can make a course post, which have a course header and a course line, and they make an implementation of registration header and registration line represented by the iRegistration header and iRegistration lines from before, and everything would work because the factory doesn't care that it's a seminar registration header or a course header it receives. It simply just gets the data. And that gives us some pros, but certainly also some cons. The pros being that there are no database dependencies. We are completely in control of everything just because we're building it. So others can't hijack into it with inserts, with temporary records, anything, because we build our things from scratch. We can mark everything and we can reuse everything across the table. And in our case, we only have one expensive end-to-end test, which is even faster than the earlier one because we are skipping all the components with spies. There are of course also some cons to that. It gets way more complex. And often if you're not intent on reusing it across different records, it also gets to be overkill. And we lose a lot of functionality from the database operators, such as test fields. As we saw, we need to rewrite that to our own testing, but also inserts, query in records, etc. And the same cons as with the componentized, all our testable units should be non-local for whatever we want to test specifically. And that leads us to the golden middle. We want to make mockable units, but we also want to have direct database object connections. And there's a way to get around that. Well, at least a compromise that we can live with. If we simply just make our records temporary, which means we will not have any direct dependencies into the code where we have a local var for a record. Everything will be passed in by reference with a var, and then we are in control. This means that we, from before, we still have the iRegistration header validators, registration line validator, etc., represented by interface, which are translated to code unit implementations, but we are now using the direct similar registration header and similar registration line, which makes it more accessible. And we'll just make a quick demo of that. So we go into this and we go into this. Means that as before, we still have our big component here. We still have the factory. So we are keeping a hold of the factory with all the code units. But now when we call the check mandatory header fields, we send the record. So if you go into the implementation of that header, which we have here, we can see it's back to the original with test fields or inserts or queries, whatever. But all of our direct database dependencies are in the header as var parameters. So we can put stuff into it and we can retrieve it when we get back. With a temporary record, we need to make it var in order to maintain whatever has been posted into it. And that means when we go down to this, we still have quite simple. Now we don't provide stop anymore. We are back to the componentized logic where we create a seminar registration header as before. Simply just populate the fields and we push it in. And the test is exactly the same as the component because right here, we are only testing the components. The component tests are identical to the componentized version, but we don't need to have 4 expensive runs. We can make use of the spies and just have one expensive run where we assert that we are using the different components. And the pros and cons of that, because there are pros and cons with everything, all code units are still mockable, and we maintain the table functionality as we went through with the test fields, etc. And since we are using temporary records, all our database transactions are cached in the temporary memory rather than writing directly to the database. There are some cons to that. We have the database dependencies back in place. We trust that everyone respects temporary records. So if someone has a subscriber on an insert of a record, they of course check if it's temporary, and still all test units should be non-local. But using either componentized solid or the solid principle, I think the test plan will still need some rework, Luke.
Yeah. So how to make the test plan a solid test plan? Let's have a look. So let's say, well, back to the slide where we more or less left, well, not really, but where we looked at before on the componentized test plan. You see here we have 4 implementation tests and the rest is unit tests. What does it mean for a solid test plan? So with a solid test plan, as Christoffer mentioned, the happy end or the end-to-end flow, the happy flow, is now no longer a full implementation test, but we check whether all of the components are touched by those spies. Yeah, so you run through the whole business logic in the flow, but the components are replaced by a spy. So that's what we call here a flow test. And all the other parts are now fully unit tests. Yeah, so we don't need for each of the component implementation and end-to-end test. No, we can now check just the full component only. We don't need to check the component logic within a whole flow. And that ends up, if you memorize a little bit one of the charts that Christoffer showed in one of the previous slides, you can see on the left side, we're testing with the first test, the one now blue marked, the flow, so the seminar post end-to-end, happy flow. It touches upon all of the components, and in our case, the 3 that we abstracted and used for our presentation here. On the upper right side, we have the component, the validator that validates the header with 8 unit tests only, so 7 positive, negative that was in the original plan also identified, with an additional positive test to check the component working in its full extent. Then on the right side down, well, the lower side is not fully in view for me. I hope it is for you. But the one on the top, on the bottom, is the component, the registration line validator. Yeah, so is the line valid? 2 + 1 unit tests on that one, and at the bottom, one linking to the existence validator for the registration line. Do we have lines or don't we have 2 other ones? So now we have one costly flow test, which is less costly than the implementation test because it only touches the components and registers that these have been indeed triggered. And then we have 13 fast unit tests. If you go back to the part where just before the golden middle that Christoffer discussed on a component solid test or a componentized solid whatever test plan, you could say, yes, this still applies, this whole structure here, except for the fact that the code behind is now still making use or has still a coupling to the database structure. We're handing over a seminar registration record, although a temporary, or where we hand over a seminar registration line. So we've linked the plan to the components. Well, we're almost at the end. All the test examples, and yes, this is a quick run through of what we've been working on last year. We've done parts in a more extended way, but let's say this is at this point in time our end station. We might move on, but we made the whole journey from full end-to-end testing, functional testing, into well, still functional test plan, but having majorly unit tests. You find all the examples here on our GitHub, or it's actually my GitHub, with this repo, so you can find all the things. I think we uploaded everything we changed recently, and that's it, I guess.
Yeah, everything has been changed. If people want to go through it, for those who are not accustomed to it, we are using preprocessor symbols to switch between activating the different code units in the different stages. There's a little text.
Yeah, it's not shown here.
There's a little text, the different paths. The last thing I just want to mention before we completely go forward, by moving to the solid or the component solid, we also achieve one major strength in my opinion, where we are not dependent on the execution of the flow. So if we restructure our code and we haven't defined that we want it to be executed in a certain way, our codes won't break because we simply just test that they are reached. Again, if you have a test and you say you want this to be reached first and this second, you might have a single instance where you just log every visit, have a pattern for that. That's up to you to structure, but you can make it way less brittle compared to the earlier steps. We had both the componentized and the structured and unstructured.
If you go to the directory of the code, there you can show the text file. There you find the different tags.
We have mentioned. Compiler directory here, and in here we have the different compiler directives which you just replace in the app.json and the test app.json, and then different parts of the solution becomes active.
So, any questions? I don't know if there are any questions, Henrik.
There is, and this is it's a long question, but it's a really good question. It says here, looks like it will take me some time to create these tests as you have shown today. Do you have any tips for getting started and speeding things up? Did you use Copilot when creating these tests? If so, how well did that work? And it looks like it would take some, yes. So that's the question that has been posed.
Yeah, I can take some of it and then Luke can supply. Copilot is really receptive to structuring it this way because it sees a pattern when you have a lot of these naming saying invalid posting date, etc. So it gets, after we've written the first 1 to 2 tests, it gets the syntax and writes it quickly for you afterwards. But again, it depends on where you start. If you start with saying, I have code I would like to make testable, well, start by identifying areas, move them to a component, and then represent them with an interface, and then decide exactly, of course, what you want to test. But once you have structured that way, Copilot quickly joins it. Else, if you're starting from scratch, you haven't implemented anything, or you just want to re-engineer it, the first slide we looked upon where you saw all the flow going through is a really good start to see this is actually what happens in the entire flow and which areas do we want to test. You might want to test all the areas. Excellent. Then you have a lot of different components you can create from that, and you can make a quite fast end-to-end test because everything is componentized and you don't care about the execution of the component, just that you reached them. So Luke.
What you might show, Chris, is the code of that original spaghetti code unit, the posting code unit. One of the things we did there is, I don't know if it's this one, but it might be. We went through the code because we had the code already, and of course we had the diagram also, but we put notes in it. Probably, well, we didn't prepare this one.
I think it
to-dos. If you go to the to-do tree, I don't know if you have that. No, you don't have it there, but we put to-dos in. So more or less, like Chris said, go through your code and identify the parts. We put to-do tags in our code. Yeah, you can see it here. So we use the code in this case because we had it already as the example, and in this way we identified what we wanted to see as testable units. You can see on line 75, check dimension. We decided not to use that for our research and the demos, but that way we went through. These are parts that contains logic of ours. Yeah, so going back to where Chris started, what to test and what not to, we more or less went through things like these are ours to test. So these are components that we want to take out. And next to that, what I achieved, and I'm not saying it will be easy, but with the test plan, if you have a full or a very complete enough set of tests, you can, or scenarios, you can identify which scenarios actually are variations of each other. And that makes already clear, even though if you did not code anything yet, that's a component. If you have, like in our case, 7 tests that all are positive, negative ones, so they're hit upon an error, checking the header, that is the header checking
and
unit.
I would even be so bold as to say that if you have a full end-to-end, that's one test. every test you have under that, that's a component, because that's a stop along the way or something you assure on the way. You can extract that out. There might just be one test for the component. Okay, that's fine. But that's still a test you can isolate, and you can isolate the component. And then whenever you want to say, oh, I want this to do more, I only have one test for it now. But now you only need to look into the structure of the 5 lines in your procedure and write new tests for the extra 2 lines added instead of understanding the entire 400 lines code unit. So that's the major given for me, that it's so much easier to access and maintain afterwards when someone else or myself who have forgotten what I made 2 months ago go and say, oh, I only need to read up upon 5 lines of code rather than 600 lines of code.
Yeah. That's something you often mentioned, Chris, and I really appreciate that also. It's more or less hidden in what you said right now, but it's easier now if you identify the components to let it be created by different developers. You don't need to have one developer to know the whole flow. You can just say this is a component with those requirements. And like you said just now, Chris, is the maintenance of getting in that component only is much faster to do that. I hope that's sufficient.
When you structure it this way, the component codes will run in 1 to 2 milliseconds per test, which means that even at a large project where you have 3,000 tests, the componentized codes, which you will run every time you made a change, should take around 5 seconds, 3 to 5 seconds to run, compared to having 3,000 end-to-end tests, which take 2 to 3 seconds to run. Well, no one has time to wait for that. Then you hit run everything and you go take your lunch, and then something broke and you need to run everything again. So it's lightning fast to test all of them. And then the end-to-end tests, I usually split them up in different code units, and I run them on my pull request in GitHub or DevOps.
Okay, that was a very long answer, and it sounds
also
like
a long question.
Yeah, but and it sounds like you could go on for another hour just answering that question. But we do have a couple of more questions in the pipeline here. Christian also asked, these techniques do not apply to performance tests in AL, do they?
Not really. You're always hooked to data there. It's not about units. So I would say no.
But still, that depends on what you want to test, because if it's a performance test of simply storing something in the memory, sure, but in performance test, you actually want to test something being written to the database, and there they won't apply. The code structure will not prevent performance tests. So if you structure it this way and you run some performance tests, sure, you just don't inject any spice or anything. You just run the full Monty, and you don't use temporary records. So you can easily do performance tests with this code structure. It doesn't prevent performance test.
That's a good answer. The next question here is, when you do the check mandatory fields, do you copy the behavior of the same procedure in the post routine? How did you determine the functions in the interfaces?
Well, that's, again, we only plucked 3 from the original flow we saw with all the different steps. We identified 3 and say, these are breakable areas that they threw an error. It might not be that you want to test that throws an error. It also might be an equation you want to test that, given different parameters, it has different outcomes. But there are different ins and outs. So if I just quickly go to the original code and we go here and we go to this is unstructured. So I can't remember if we have the check mandatory header fields in this one. No, we will have that in number 2 where it was structured. So if we go to the check mandatory header fields, which we have here, we saw that this could throw an error on runtime, this line, because test field throws an error. So that's a test that it still throws an error. This can throw an error. That's a test. This can throw an error. That's a test. This can throw an error. That's a test. So forth and so forth and so forth. If we wanted to test upon errors being thrown, it could also, as I said, be a calculation saying, given different parameters, it could give different results. Then I would create tests upon that. But every time a code can have different results depending on the income and outcome, I want to test that I reach all the outcome. Yeah.
And one last question here. So that's come in. Could you imagine a workaround with the local dilemma by using interface implementations? Test an app, for instance. If your end-to-end test only test the global procedures, unit tests can test against the test implementation of the interface.
Well, even if you had, I'm not quite certain I follow what you wanted to do, that you still need with your interface, that's also procedures that's into that. So you expose your procedures through the interface, and that means they're global, might be internal, and as Luke said, internal is only visible through your app JSON, and you can build in your pipeline that it removes the internal visible too if you want to. But did you get what he wanted to do, Luke?
I'm reading it also. I'm not fully aware, but I think crucial here is the global level. With any interface implementation, the interface will be defined by global methods, right? That's it, or internal visible methods, whatever. Testing against the test implementation of the interface, I wonder if it's really needed. But maybe John, you're hitting up on something.
I would invite John to speak up if he can.
I'm trying to imagine a scenario where you have your local procedures like aware somehow, like you expose it, it looks for perhaps a global variable that's set so that it not an event, but so that it runs custom code. It's listening for the test implementation to set perhaps a variable on that.
Well, that would be actually what the factory is doing. So if you, first of all, you can't put a local procedure in the interface, just to show if that's it. But if you go to the factory is saying exactly, right now we are using the registration header validator, which contains our actual code on runtime, which have the check fields, the test fields, etc. But our test code unit says, if we go down to that here, our test code unit says that we are using, if you go here, we're using our spies instead. That means that it won't reach our actual implementation. It will simply just reach our spy, which says, this says, no errors is thrown. You have walked through, so that will execute this code rather than the code we had, here, if that makes sense.
Yeah,
that's the whole idea of the factory, that you can, let's say that we took the original flow and we componentized everything. Then we can replace everything with spies, and let's say it was a flow where you had first this will go, and then the second part, and then the third part. Then we could mock up the first and third part and only test on the second part. So that's exactly what the factory is for. That's for maintaining, if you want to use the runtime implementation of the interface, or you want to use the spy. And again, of course, there can be different implementations of interfaces, even in runtime.
It just seems like if you say have a code unit that does one thing and you have one global procedure, and then you have 10 locals that support that main procedure, is it fair to just test the one global procedure and just leave all the rest of them local, or does that violate the componentization?
You can have as many locals as you want in your component, but your test should still cover all the ins and out of the procedures that goes in. It will still be fast, and it's a question about structure. So let's say that this one was split into 1, 2, 3, 4, 7 local procedures. Wouldn't make sense, but let's play with it. So it has check mandatory header fields, so that would first call local procedure test status, local procedure posting date, etc. Sure, you can do it like that. Then again, if you do it too much, you will go back to that your component is unstructured spaghetti. But you would only have one way in, and you should for certain use local procedures. That's the open close principle from Solid, where it makes sense. But just be aware that your tests should still cover whatever is doing in the local procedures if that's a part you want to test upon.
So just to be clear, you're saying don't put local procedures, don't create you have to take a local procedure that wouldn't make sense to be global in an app, but it would make sense in a test because that's the only way you can test it. So it's purely for testing.
Yeah, but be careful also. I mean, look at it also from a functional perspective. The component here, check mandatory hero fields, is based upon a functional part in the flow. Yeah. So it's not about componentizing every part and make them exposable and testable. It could be, but look at it at a higher level. What are the components that make up your process? And those components are the things that you test. But and even if they're a bit more complex with locals,
that you need to expose it in order for tests to reach it. It is. Again, the workaround, if you don't want to endanger that it's been used by a dependent one, is to remove the internal. And that's a trade-off that you more or less will have to live with. That the pro is then again, if I want to understand this code, it's only 10 lines of code. If I want to expand upon it, I simply just write another test field, and then my code is this one as an example. Then my component unit test would fail on the valid because I haven't provided one with a valid minimum participants. And yeah, so that's the trade-off. That's, as far as I know, there's not much workaround. You could have where you say, if something is said, do this code, else do this code, but that's really why we have the interface saying you use whatever implementation you want of that interface, doing what you want, and then that control it instead of a global parameter you set.
We want to thank everybody for participating. Look up the Europa webinar on YouTube to catch up with the previous episodes. Thank you everybody for participating and have a good day.